Welcome to qnawire.
All right, we've got a question here. We want to evaluate the double integral s curl of f dot d of s. And we have our f given with our I, j, and k values. And we have this s as a hemisphere. X squared plus y squared plus z squared equals to 16 when y is greater than or equal to 0. All right, so the objective is to evaluate that integral. Write that out. Double integral s curl of the dot product curl f of d of s. All right, we know that this can actually be rewritten as a integral of c with the domain c of f dot dr. All right, so what we're going to do is take our r, which will be, you evaluate your, from the surface, we can find that our r will be 4 sine ti. Our j will be 0. Then our k will be 4 cosine tk. Okay, once again, just to clarify, you're going to take your f function that was given, f x, y, z, which was z e to the y I plus x cosine yj plus xz sine yk. And what you're going to do is you're going to put in some kind of a program, whether it's a graphing calculator or a MATLAB type thing within your computer, and you're going to plot that, and you'll get a surface image. And using that surface image, you can get your equation r. Then when you take d of r, we'll have that d of r is equal to 4 cosine ti, still your 0j, plus, minus a 4 sine tk. That'll be with respect to t. All right, and then your f of r of t will then be equal to 4 cosine t e of 0 I plus 4 sine t cosine of 0 j plus 4 sine t cosine t that's going to continue to be multiplied by sine 0 k. And if you simplify that, you'll get a 4 cosine t I plus a 4 sine tj plus a 0k. All right, and then you can take that integral of c for f dot dr, write it out as 0 to 2 pi for the circumference. And you have your f, which is 4 cosine t, your I plus your 4 sine t, your j plus your 0k, all of that multiplied by your d of r that you wrote out, which is 4 cosine ti. So it'll be 4 sine tk d of t. All right, once you go ahead and actually simplify this, you will get to the answer that is equal to 16 pi. All right, and that'll be your final answer there. Once again, I hope that clarifies the question. Thank you so much for watching.